What's up guys, today we're going to be looking at building an aluminum frame for your LED lighting system. There's a number of different ways that you can do this, but the method that I'm going to show you is pretty simple. It may not be beautiful, but it's pretty easy to do and requires some very basic hand tools that you probably have kicking around the house. While we're starting to see more and more manufacturers offer their own pre-made frames, it's always nice to be able to build your own and customize it to exactly what you need. In this example, I'm going to be building a frame for a 2x2 tent, and it's going to house 4 Citizen CLU 048 1212 COBs. If you're building a frame for a 3x3 or a 4x4, the same principles and methods apply, so you can kind of scale this to whatever size or shape you need to build for, which is the beauty of a custom frame. Alright, let's get right into this, and we'll start with an overview of the different tools and components that you're going to need for the job. First off is a measuring tape. You're going to want to be pretty precise with your cuts or else you're going to end up with some oblong, junky looking piece of crap frame. So a measuring tape is pretty much essential. Second is a set of ratcheting hangers. You can find these pretty easily on Amazon or eBay. Just make sure that you get the right size and that the hangers you buy are rated for the weight of your finished product, whatever that may be. I'm only using 2. You could use 4 if you wanted to use a hanger like this in every corner of the frame. But I'm going to use these in conjunction with these other little metal hangers that I have, and I'll show you later on how that works. Next up, for the frame itself, you're going to need 1/8 inch angle aluminum, and I've used 3/4 inch by 3/4 inch by 1/8 inch, and you get these in probably 8-foot lengths. I only used a couple lengths to do this, but if you're building a bigger frame, you'll obviously need more. I wouldn't go any lower than 1/8 inch. I think a 1/16 of an inch is going to be too flimsy for holding up anything substantial, so stick with 1/8 just to be safe. In terms of hardware, you're going to need a couple different types of screws. First off, you're going to need screws to secure your heat sinks to your frame. In this case, these heat sinks require M3 screws, so I've got a little pile of those. And then you're also going to need screws to attach the different pieces of the frame together. So what I'm using is number 6 screws by 1/2 inch long, and they're self-tapping screws. So I'm just going to drill pilot holes and then drive these self-tappers through, and they have sort of like a drill bit on the end of the screw almost that allows you to bore through the metal, and then it taps its own hole on the way through, so it's really handy. I'm also using a run-of-the-mill cordless drill, and you'll see in the video I kind of cheat because I'm using a drill for the actual drilling, and then I've got a little impact that I'm using to drive the screws in. So you can do this with just one, but if you've got 2, it's really handy to not have to switch the bits out constantly. And then I've also got a couple drill bits. I've got a 7/64th, and that's what I'm using for pilot holes for these screws. It seems like it's a good size that's not too big. It still allows the screw to bite, but it provides a good pilot hole. And I'm also using a 7/32nd, and that was just because it was pretty much what I had handy that wasn't broken in my drill index. I'm using that to drill holes for some tie wraps just for cable management afterwards. So they're funny sizes, so if you have different size bits, you know, something more common like an 1/8 inch or similar, and it's small enough that you're not going to drill out the hole too much for the screw, you can obviously use whatever you got, but just make sure it's a good fit and it's not going to bore it out too much. And the last few items on the list, I've got a little bit to drive the screws. I'm using Robertson screws because they're the shit, and it sucks to be American and not have these things. I'm also using a Sharpie to mark all my holes and lines for cuts and whatnot, and a Phillips screwdriver for the M3s. And then finally, I've got some tie wraps that I use just to manage the cable and keep it nice and tight on the frame afterwards. Now that you've got your tools together and you're ready to buy your aluminum, you probably want to know how big you need to make your frame. And that's going to depend on a couple things, one of them being the size of your grow space, and the second being the number of LEDs that you're using and the way that you're going to lay them out. In a smaller grow space like the 2x2 that I'm building for, you can make the frame pretty much just about the same size as the space, obviously just a few inches smaller so you're sure that it's going to fit inside of it. Here I'm going to make it 20 inches by 20 inches, and then that'll allow me a lot of flexibility for moving my COBs around right to the corners to experiment with spacing and make sure that I don't get a hot spot in the middle. But as you get into the bigger sizes like a 3x3 or a 4x4, you might find that the bigger you go, the smaller your frame is relative to the grow space. So where a 4-inch difference in a 2x2 might make sense, you know, having a 20-inch frame and a 24-inch width, when you go to a 3x3, you might make that a 30-inch frame and a 36-inch width, and a 4x4 might be a 40-inch frame and a 48-inch width. Really, it's going to come down to whatever makes more sense to you, and however many COBs you have, and how many rows of COBs you're doing, and so on and so forth. When it comes time to cut your aluminum, there are a couple things that you need to make sure you do. One of them is wear safety glasses, because getting these little flecks in your eye can be very painful and you don't want to have to get those scraped out. That's brutal. I've had that before. And second, make sure you wear some sort of a mask so you're not breathing in the dust that's created by this stuff, because that's pretty nasty too. There are a number of different options that you have when it comes to cutting this stuff. You can use something like a miter saw. I would recommend that you remove the little dust bag from the saw, because these flecks will melt through that and kind of ruin your bag. So a miter saw will work. You can kind of kiss the blade goodbye, because it tends to get pretty gummed up and the aluminum will probably ruin the blade. So either buy a crappy blade or use an old one. You can also use something like a table saw, which cut just fine and dandy for me. Actually, both of these made very nice cuts. If you're stuck in an apartment or you don't have a table saw or a miter saw, you can also just use a hacksaw. This thing worked fantastic. This is probably a $5 little junky hacksaw, and it worked just great. It takes a lot longer and it takes a lot more effort, but it does the job and it works just fine. So you can use a hand tool like this if you need to as well. You might find that you're left with sort of a rough edge on the edge of your cut, so what you can do is take a little grinding stone, kind of like this one that I've got in the drill, or use a grinder or whatever, and just kind of deburr it, get rid of all that sharp stuff, and make it a nice and smooth finished edge. And what this does is prevents the chance that you're going to get cut when you're working with it if there's a sharp edge on it, and also it allows you to get a much nicer joint between pieces of aluminum. So if you're butting them together and there's no sharp edges sticking out or little chunks sticking out, then you can get a much cleaner, tighter fit. Now that all the cuts are made, I like to mock it up on the bench and take some measurements just to make sure that this thing is actually going to be the right size. So as I said, we're going for a 20 by 20 inch frame, just a square here for a 2x2 tent. Two of my pieces are 20 inches long, and then the other four are 19 3/4 long. And that's just to account for the thickness of the material itself, so it's perfectly square. At this point, I've got the frame laid out, it's looking good. I've measured and verified that yes, it's actually 20 by 20 and I'm not cross-eyed. My measurements are good, my cuts are good. I can start laying out the COBs and see how they're going to look. And a frame like this will work for really any type of LED. They'll accommodate COBs on pin-fin heatsinks like I'm doing, or you could throw in something like a quantum board and just drill right up into that heatsink. You could mount your drivers to it. Really, the flexibility of these little DIY frames is what makes them so awesome. Okay, so I've got the frame laid out again, and I've got some little pieces of wood to prevent my nice new table from getting drilled into. And what I'm going to do here is drill pilot holes in each of the four corners so I can start fastening the outer perimeter together. So what I do is just put a little bit of pressure down on one of these pieces to keep them together. I've got them lined up very carefully so the edges are meeting perfectly, and just drilling a pilot hole straight through both pieces in one shot. Once you have your pilot hole drills, you're ready to put a self-tapper screw through, so switch over to your screwdriving bit and line the two holes up and then fire that screw right through. You might have to do it in stages where you put the screw through one piece and then you get the next one lined up and continue on through. You might find that it's kind of difficult on the first few pieces trying to keep them together and keep them lined up as you're screwing them together, so I would recommend finding a way that you can clamp these together and not doing what I did, which is just hold them with your hands, because I was having trouble devising something that I could do in my little camera space and was getting impatient, so I just grabbed it. But find a way that you can keep them together, maybe with a clamp or something similar to make that connection. What you're looking for when you've made this joint is you want a nice and snug fit, so both pieces should be butted up tight against one another. You want the screw to be right through, and I'd recommend going from the bottom up, so the little bit that sticks out is sticking up into the top part of the frame where you're less likely to grab it to carry it. And you shouldn't have very much play between the two pieces. Once you have your four corners screwed together and the outer edge of your frame is built, we can start looking at marking the holes for the heat sinks to fasten to the frame. On these heat sinks, there are little threaded holes on the edges, on the side, as well as on the bottom, so we can come at it from below or from the side with an M3 screw to fasten it. In this case, I'm going to use the holes on the sides, so I'm just going to throw the heat sinks into place, and I've already decided that I'm going to put them about 5 inches from the edge, so 5 inches off of the edge of the frame will be the center of each heat sink, and I'm just throwing them into place to see how that looks, and then I'm going to take a Sharpie and mark this location on each of the rails that are going to need to be drilled out. Once I had all my marks in place on both sides of the frame, I put the heat sinks back in and put this middle rail in and pushed it right over into place. So this is exactly where I want it to sit, and it's cradling those two heat sinks nicely. So I put it in place and then drilled a pilot hole on both sides of it, but I did not screw this in. I just wanted to get the pilot holes in place because we still need to put in some holes on the side of this rail for the M3 screws to go into the heat sinks, so if it's in place that would make that much more difficult. So I just threw the pilot holes in and then keep it loose and do the same for the other side. Alright, so we've got our two middle rails prepped now. We've got pilot holes on either end of the two pieces. It's time to look at mounting these heat sinks to those rails. First thing I wanted to do was measure how far up the heatsink this little side hole was, and I determined that it was about 3/16 of an inch. So I took that measurement and then added the thickness of my material, which is 1/8 of an inch, and I knew exactly how high up I would have to drill on my piece in order to hit that hole at the 5-inch mark. Ideally, the holes that you drill through your frame are going to perfectly line up with the holes that are pre-drilled in the heatsink, but chances are this isn't going to happen. I mean, a couple of mine were a little ways off too. So what I did was just use a bigger drill bit just to give myself a little more wiggle room, and so long as the size of your hole is smaller than the head of the screw, then you're good to go. And even if it's bigger, then just use some washers or something, but the smaller you can keep it, the better. It'll just look cleaner. With 4 COBs, you're going to need 8 of these holes. You'll have 4 on the middle rails and 4 on the outer rails. And as you're drilling these out, it's a good idea just to check and make sure with each hole as you go along that they're actually lining up. So grab a heat sink, throw it on the rail, and make sure that you can actually get a screw through your hole into it. After you've got all the holes for your heat sinks in place on your outer rails and your middle rails, it's time to fasten the middle rails down into place. So we can line them up with the pilot holes that we had drilled earlier and then fire some self-tapping screws through these as well. That's it for the assembly of the frame, and at this point it should be rock solid. You shouldn't be able to wiggle it around at all. Next, we're going to screw in all the heat sinks, and the accuracy from the drilling that we did a few steps ago is really going to pay off at this point, because if you missed, it's going to be super frustrating to have to go back and bore those holes out. So take the time to do it right the first time, and it'll save you a ton of time in the long run. Make sure all your screws are tight and your heat sinks are not going anywhere, and then we're ready to move on to the next step, which is drilling out some holes so we can hang this frame. Initially, I had planned on using 4 of those ratcheting hangers for this thing. I was going to put 1 in each corner, but I decided that I had these little metal ones hanging around and I could use these instead. So I put 1 of these in each corner and then brought them together in pairs. So I'd have 2 on one side and I'd hook those 2 up to a single ratcheting strap, and then 2 on the other side and hook that up to my other ratcheting strap. I was a little bit concerned that using these metal hangers was going to end up in sort of an unlevel hang once I got them up on the 2 ratcheting hangers, but it turned out when I got all the corners drilled out and I got each of these clipped in and then did a test off of the 2 ratcheting hangers, it was actually quite level, and as long as these little straps are the same length, then you should be fine. And you can get away with these on a smaller frame like I have here for a 2x2, but as you go up to something like maybe for a 3x3, then you're probably going to be stuck having to use a ratcheting hanger for each corner. With all the mounting points complete, I moved on to the next step, which was getting cable to each of these COBs. I wanted to find a way to keep it somewhat organized, and nothing amazing, but just a way to maybe keep the cable tight to the frame and keep it from flopping around. So I decided I would put in a bunch of holes with my bigger bit and make sure that the hole is big enough for a tie wrap to fit through, and then just sort of centered them and put them in a few different strategic locations where I know I would need that cable to be tight to something. So I did right between the COBs and then around sort of the frame, around the edges where I knew that I would be turning a corner to go across to the other side, and so on and so forth. And just kind of went willy-nilly, put some holes in here and there where I thought it would be advantageous to keep that cable strapped down. After drilling all the holes out, I fit each one of them with a little tie wrap. These things are really handy for cable management. And at this point I was ready. I had my loops and was able to move on to actually passing cable through the frame to each one of the COBs. These particular heat sinks are quite nice because they have a hole in them that allows you to pass cable from below to above the heatsink. So you can kind of come down through the fins and then onto the surface of the heatsink to plug into the COB, which keeps the cabling very neat and organized. I did just a basic series circuit on this, so positive to negative, chaining all the COBs all the way through, and then once all the wiring had reached each of the COBs, I tightened down all of my tie wraps and then snipped the ends off of them. Whenever I'm working with tie wraps, I like to use a little pair of Giron flush cutters or micro shears or whatever you want to call them to cut all the ends off of the tie wraps. And the advantage to using this little tool is that it cuts so close and so cleanly that you can run your finger right across it and you won't even feel it. It's just such a nice trim to the tie wrap. If you use a normal pair of cutters, it's going to leave a little tab that sticks out and it's going to be razor sharp, and you can just about guarantee that when you go to pick up the frame or you're moving it or something, it's going to leave a big scratch on your arm or a big cut or something. So if you're looking to not bleed to death on your table and you work with tie wraps quite often, I would certainly recommend grabbing a pair of these little flush cutters because it's so much neater and it makes it a lot safer too. Now, after giving that whole spiel, do I have my flush cutters on me when I'm doing this build? Of course not. So I used another pair and just kind of half-assed it, and then came back with the good set that I had and cleaned them up afterwards. When your wiring is complete and you're confident that everything is as it should be, it's always a good idea to test it on the bench before you put it in place, because it's a lot easier to troubleshoot when it's sitting here right in front of you as opposed to when it's hanging upside down in the air. So take a few minutes to test it out beforehand and it might save you some time. You may have noticed by now that I haven't made any accommodations to mount the driver onto the frame, and a lot of people like to do that. They'll add a couple more rails and then throw that driver right smack dab in the middle and have sort of an all-in-one fixture. But I prefer usually to run my driver remote for a couple reasons. The first reason is that if you bought a kit or something and you got an A-type Meanwell driver, then it's a lot harder to get at that little potentiometer screw when this thing is flying in the air, and much easier if it's remote somewhere on a shelf or what have you. The second reason is for temperature. That driver's going to put out a little bit of heat, and if you have it inside your tent, it's just going to make things worse if you already have problems. So running it remote can prevent additional heat buildup in the tent. One strong argument for putting the driver onto the frame is safety, something that's often overlooked on these little aluminum DIY builds. If you have a frame that's not grounded and one of your wires were to come loose, let's say a wire off the driver makes contact with the frame and the frame is not grounded, then that thing is electrified and there's no path to ground. So if you were to go up and touch that thing, that electricity is going to go through you to ground and you're going to get shocked or worse. Now, I'm not a professional electrician, and I would actually love a real electrician to chime in and verify this, but at any rate, take this spiel of mine with a grain of salt. But if you have a driver with a metal case that's grounded, like a Meanwell HLG series, which is pretty much what everybody uses, then if that driver is mounted to your frame and there's good solid contact between the case of the driver and the frame, and assuming that you've hooked up the driver correctly, you've terminated the ground wire and that's making it all the way back to your outlet, which is grounded properly, then your frame, through the contact with the case of the driver, should also be grounded. I'm doing a little experiment here to check on the grounding. So I have a power bar that the driver is plugged into, and the power bar is off just to be safe, but we can still check the ground. So I have my meter set to resistance, and then one probe, the black one, is underneath the driver making contact. The other red one is plugged into the grounding plug on the outlet. And I'm seeing 0.4 of an ohm, so that indicates there's a good ground between the case of the driver and ground at the outlet. If I check on the frame with my black probe, it's open. So there's obviously no grounding between the frame and the grounding plug on the power bar. Go back to the driver, it's at 0.4. So then what happens if I put the driver onto the frame and the contact is made between the aluminum frame and the metal case of the driver? Well, put the red probe back into the grounding plug and then check again on the frame with the black probe, and now that the driver's sitting on it, we're going to see a ground being made. So there's very low resistance. There's 0.5 of an ohm, which is an excellent ground. So this is, again, a big pro in the argument for mounting your driver to the frame is the safety of it. And if you don't mount your driver to the frame, there are other options. You may have to get a bit creative. In my ceiling, for instance, in my unfinished basement, I see there's a ground wire that runs through just freely, so I could hook up to that and then attach a wire from there to the frame, or you may have to get creative, but if you have to do a remote driver install and you want to still play it safe with the grounding, it can be done. Okay, that's going to wrap this thing up. What you're looking at now is the finished product. and I think it turned out pretty good actually. This frame is very solid, the wiring is somewhat managed, and overall it looks pretty clean and pretty neat. And shit, the light even works, so high fives all around. As always, if you have any questions or comments, please leave them below. If you have any suggestions for improvements, I'm always open to different methodologies, and there's a million different ways you can do this. I chose to do it with screws because I prefer using a drill, and I like the ability to move the rails around and whatnot, but you can use rivets or nuts and bolts or whatever. So if you have suggestions, please leave them, and good luck on your own build, and we'll see you next time.